Hey guys, so today we're going to be talking about imaginary numbers. Okay, so the first thing that you need to know is basically imaginary numbers come from our roots, our radicals. So if we have a square root of negative 64, this isn't possible, right? Because a square root is if you had a square. Squares are special because each of the sides are the same length. So the area of this square, let's just say it was 64. So if the area was 64, that would mean the length times the width would give us the area. So area equals length times width. This would have to be the same number because it's a square, and on a square, all of the sides are congruent. They're all equal. I know that if I had 8 times itself, that will give me a positive 64. Or, mathematically, if you had negative 8 times negative 8, you'll also get a positive 64. We can't really measure things negatively, so this doesn't really apply to our real-world circumstance. But you can clearly see that 2 positives make a positive and 2 negatives make a positive. Here's the thing. When you're talking about the square root, you're talking about one of the sides, right? So they have to be equal to make a square. So I can't have negative 8 times 8. That's not a square because my sides are not equal. Or 8 times negative 8. This is not going to work. So this is impossible, except we can do it with imaginary numbers. So we're going to talk about those today. Basically, imaginary numbers are I. I for imaginary. It's a lowercase, cute little I. You have to be careful that it doesn't look like a 1. That's why we don't capitalize it. And basically, I equals the square root of negative 1. I squared would be 2 of these guys, right? So negative 1 times negative 1. Well, if I have a square root and the same thing times itself, it's just that number outside of our root. These are the 2 most important ones, but the pattern continues over and over. So for example, if you had I cubed, well, that's the same thing as I times I squared. Well, I is, well, we're just going to call I. So I is I, and I squared is negative 1. So I times negative 1 is negative I. So that's what I cubed would be. I to the 4th power is I squared times I squared. Well, I squared is negative 1, and I squared is negative 1, and negative 1 times negative 1 is 1. And we could keep going. I to the 5th is the same thing as I to the 4th times I. Well, I know I to the 4th is 1, and I is I, so 1 times I is I. And I to the 6th is, well, you could do I to the 3rd times I to the 3rd if you wanted to. It's nice to do it with the 4, but whatever. So I to the 3rd is negative I, so I have negative I times negative I. Well, negative times a negative is a positive I, and since there are 2 of them, it is squared. And I squared is the same thing as negative 1. If you notice, there is a pattern that keeps repeating. So I is just going to be I squared is negative 1, I cubed is negative I to the 4th is 1. Then we start over the pattern. I to the 5th is I to the 6th is negative 1. So I to the 7th is, wait, where did we go? I got lost. Okay, right there. So I to the 7th will be negative I to the 8th will be 1. I to the 9th is starting all over. So 1, or an I. Okay, so this pattern is going to keep going forever and ever and ever and ever. So we're looking at groups of 4 for these. This will come in handy on our worksheet. Also, you need to know complex. These are also called complex numbers. And the way that we write them is we write A plus BI. So A, this is our real part, and B is our imaginary part. And I is, well, any variation of the I. So I squared is -1, and I is the square root of -1. Those are the two most important ones. Okay, so let's do some problems together. Okay, so on the first little bit today, we're just simplifying complex numbers. So you need to combine the real parts and then the imaginary parts. So think about it like if I have 2x plus 5x plus y plus 8y. Well, if this is my expression and I want to simplify, I would add my x's, so I'd have 7x's, and I would add my y's, so I'd have 9y's. Well, it's the same thing here. You're going to add your real parts and your complex parts, or your imaginary parts, whatever you want to call it. So -2 plus 7 is 5, and -7i, and I have this -4 minus 7i. So 5 minus 4 is 1i, and I don't have, or 1. I don't have anything else to combine that I with, so it just goes on the end. Okay. Number 2, this cute little negative in front, you have to distribute that first. So we have -3 plus I plus 5, negative times 2i is -2i. And then add your real parts and your imaginary parts. -3 and 5 is 2, and 1i minus 2i's is -1i. Okay, and you write them with the real part first and the imaginary part at the end. Let's go down here. This guy. Okay, so remember how the pattern repeats after 4. So the easiest thing to do is some math. So we're going to do 63, and we're going to divide that by 4. When we do 63 divided by 4, we get 15.75. Okay, so I know that 4 can go evenly into 36 15 times. I'm not going to worry about that decimal. So 4 times 15 is 60. So basically, I to the 63 is going to be I to the 60 times I to the 3. Because 60 is a multiple of 4, and anything to the 4th power is just 1. So it's going to be gone. It's just the number 1. Okay, so I to the 60 reduces to 1. And then I to the 3rd, if you want to, you can go back to your cute little chart. So I to the 3rd is the same thing as -I. So it's 1 times -I, which is the same thing as -I. Okay, and the same thing like on number 42, or for 42, I would start with dividing 42 divided by 4, because you want to see how many times 4 can go evenly into 42 since it's a bigger number. Like 16 is easy, you know that 4 goes into 12, but anyways, and then you would find your leftovers, and your leftovers are going to be less than 4. Okay, then at the bottom, over here, we have some complex roots to simplify. So the way that you do this is you are going to, let's see, I'm going to try to do one. I'm going to do number 19. On some of these, remember on this root, all it really is the square root of -8 times -32. And when you multiply those two numbers together, you get a positive 256. And if you check that in your calculator, the square root of 256 is 16. So, I mean, these guys where they're like multiplying them together, then like actually multiply them and see what happens. Number 18, let's do that one. So on this guy right here, you need to think about this a little bit differently. So it's going to be the opposite of what we did here. This is going to be the square root of -1 times the square root of 81 times the square root of x to the 6th. It's better if you break them apart. So the square root of -1 is I, and the square root of 81 is 9, and the square root of x to the 6th is x to the 3rd. But now we got to write this in a much better order, because this looks bananas. So we are going to write the leading coefficient will be our number, and then x to the 3rd, and then the I at the end. The same thing happens on number 19, but when you reduce, you're going to be like taking out a number. So 12 is 2 and 6 and 2 and 3, so I can take out a 2. The other one goes away, and I'm left with 3 under my radical. Remember, when you take this guy out, he needs to be multiplying. So I'm basically separating the idea of 12 times -1, and I'm just focusing on my 12 for right now. These are both under my radical signs, but we're not thinking about that just yet. So I'm going to take out a 2 on my 19, and I'm going to multiply my 6 by it. Then left over, I still have my -1 in my radical, and I have multiply, not add, and I have my root 3. I know that the square root of -1 is I, and 6 times 2 is 12. So this will be 12I root 3. Okay, let me know if you have more questions. We're going to be practicing this for a long time. Okay, have a great day, guys. Bye.